The other kind of tricky part with this is the numbering of your devices. So for like a 6300, just a regular 6300, all of our 6300s would have the interfaces that they're using, like this interface right here, would be numbered starting with 1 on the top and then 2 on the bottom, 3 on the top, 4 on the bottom, 5, 6, 7, and then 8. So this would be port 8. To refer to it, you don't just say interface 8. You say interface 118. It's like 1/1/8. But the 1 and 1, what that refers to is the member ID. If you have more than one switch, you could member this 1, member 2, member 3, if you wanted to use them all as if they were a chassis. Now, this isn't a chassis like a 6400, but you can pretend it is with a feature called virtual switch framework. It's what we call switch stacking. So every vendor out there uses some sort of stacking technology, and HPE networking is no different with Aruba switches. With this case, you can designate which one is which if you group them all together in a stack by assigning member IDs from 1 to 10, because VSF supports 10 switches maximum. If you're not part of VSF, then guess what your member ID is? Your member ID is always going to be just 1. So you can almost kind of ignore the first number unless it's part of a stack. It means something, but otherwise it's just 1. The second number is if it was a literal chassis, like if it was this example down here where we have this chassis and we wanted to refer to the line card that we were interested in. Like let's say it was this line card right here. Well, the way we number our chassis is the cards within them is we use 1, 2, 3, 4, and it just continues along like I showed earlier. So the second number would be the slot number. If you don't have slots, then it's just 1. The whole thing is considered slot 1. So if you're not part of a stack, you're member 1. And if you're not part of a chassis, you're slot 1. Just 1 and 1. So all the ports here are always going to be 1, 1 something, like 1/1/2, or 1/1/40, or 1/1/48. If it's a chassis though, then you can designate 1/slot number, in this case slot 4, port number 8, for example, for the first member, because it's member 1, for the fourth slot, because it's slot 4, and then the 8th port, 1, 2, 3, 4, 5, 6, 7, 8. So it'd be this port right there. More than you ever need to know, right? So anyway, that's how we keep track of all this, even though we have technologies like chassis, and even though we could stack even chassis together using a stacking technology like VSX, Virtual Switch Extension, which has 2 members, member 1 and member 2. Let's take a look at the lab activity that we're going to do. So the first lab that I demonstrated was getting into your PC, double checking what your IP address is. What we want to look at now is how do we connect to a switch? How do we show traffic on a switch? Like how do we get help if we don't know what a command is? How do we view the configuration somebody already did for us on a switch? How do we show frames? All of that. In the device at my house, I was just opening my browser. And so the way I would configure the device at my house is through my web browser to open it up. And then the graphical user interface would allow me to make changes to my local connections, my wireless radios, and even my public internet. I could change all that through my browser. You can kind of do that with these switches as well. Because my management port is up and running through my network, I could technically connect to the switch. So if I already know what my address is, I can just open up my actual browser on my home computer and get to it. Because if you remember, this network cloud here indicates my house that I'm connected to. And so in my house, I have my computer with my .8 address, right? 192.168.1.8. This address should also be in that same network, that /24 same subnet. And so therefore, I should be able to get to it without having to do anything fancy or crazy. So let's see if it did, if it pulled an address. I'll click on it to open it up. This should give me command line access. I'll press enter to get my prompt. And let's log in as admin. By default, I didn't put a password on these, so I'm just going to press enter. And then if I want to view my management interface, I'm going to do what's called a show command. Show commands are how we use our commands to just view our settings. And one of the settings, I could hit question mark and just see all my settings. And so I could show all of this stuff. But yeah, you can scroll back and see there's just tons of show commands I could use. Show AAA, show BGP, show console, show debug, show DHCP, on and on and on and on and on. The command I want is show interface, and I could start typing it. As soon as I type enough of it to where it knows what I'm talking about, I can just hit tab, the tab key, and it completes it. So show interface. If I press enter, it'll start running through all my interfaces, starting with my first interface, which is 111, and then it prints everything to screen. And now that page command is working where I get a more option. More just means I can press spacebar and it will page down, or I could press enter and it'll go line by line. So if I want a page, I press space. If I want to show the next line, I'll just press enter. Like if I just press enter, it'll go line by line by line. I'm gonna hit spacebar. It'll go down. Ah, there we go. Now it shows interface 2. Space down. Interface 3. Oh geez, there's a lot of interfaces. Let's skip to it. Show interface space question mark. And it doesn't show the question mark, by the way, but it does take it. And these are all the show interface commands I could do. So I could just say, show me one interface, like port 1, and it will only print to screen information about port 1. Statistics about port 1, data rates on port 1, information about the port, including the port's burned in MAC address. That's kind of cool. And all the port settings. Lots of information there. That's more than I care about. So I'm going to do show interface question mark, and I want to look at my management interface. And so if I do show interface management, that shows me that it's disabled. Why is that disabled? So let's go into configuration and we'll configure the management interface, and we'll say not no disabled or enabled. You would think the command would be enabled. It's not. It is no shutdown. If you shut down a port, it is shut down and it doesn't work. But if I negate that, if I want to do the opposite of shutdown, if I want a no shutdown, it'll bring it back up. Now, before you think we're crazy for that command, that's how the whole industry does it. Almost every vendor out there does it. There's a few exceptions, but that's pretty much it. So no shutdown. All right. Now if I exit back and I type show interface management, hey, look at that. The management interface is up. It should be up by default, but somehow I shut it down. So it is up, it's running, and it uses DHCP by default. That's kind of cool. So because it has a MAC address, it can talk with other devices in my house. And another device in my house, my router, assigned it a DHCP address. That's pretty sweet. So the address is 192.168.1.19. Okay, so by testing this out, I was able to ping the address of my device, which is 19. Pretty cool. And if I do a show interface management, I can see that it did indeed have that address. And now if I go to open this at 192.168.1.19, I get a self-signed certificate. So I'm going to go ahead and accept it and join. And here you go. You have the browser for this CX switch. So I can log in with admin no password. You can go through and make adjustments and see your interfaces. I just have port 1 plugged in, 3 and 5. I've got VLANs, I've got lags, I've got users, I've got all this stuff that we haven't really looked at yet. But yeah, technically you can get information, you can update the device, you can look at traffic, diagnostics, information, ping, trace route. You can do all this stuff through the GUI. We are not going to do that. In this class, I'm going to show you the more traditional way, or not in this class. In this presentation, we're going to look at a more traditional way of establishing configuration. So turning on the device, where do we get the address? How do we connect to it? And how do we connect to the switch? So in the original demonstration we did earlier, I showed you how to connect to your PC to the network and what your home network might look like. So now we're going to look at how to connect to a switch and how to log in, and even show some basic configuration that might be on the switch before we blow it out for the next lap. Taking a look here, the console port, as we know, is part of this USB-C connection here. And you may have a dedicated console port in the back, or not in the back, but that might be available. And this one, we just had the Type-C connection on this particular model. So the way that we're going to establish our connection in the lab is we're going to open up our console connection via this GUI interface to get to the lab device. In the real world, you would just plug in a USB port there, and that would give you your console connectivity. In the first part of the lab, we're going to use this Access One switch, which has management connectivity. It has some uplinks here, and it has some ports down to some PCs that we're running down here locally. So to log in and connect to the switch, we can log in initially and do some show commands to see what the actual config is on the switch to begin with. And we did that earlier. We logged in through the console, and with that, we were able to do a show interface command and look at the different interfaces. If I want to see the configuration, we have what's called the running config. The running -config is the commands that are currently applied to the switch. There's a bunch of default commands, depending on the switch model. If it's a 6000, it's going to be a little bit different than 8000s, for example. But what the show running config does is it lists out the different commands that are on the switch itself. And if you hit spacebar, you can go down and see all these configs. What's cool about this is that you could copy this and save it to Notepad or whatever text you want and paste it into another switch, and it would apply these commands when you pasted this in. So if I open up like Notepad and I right click and paste, I've got a backup of my configurations. And so it's saved and ready to go. If you make a change, it's going to apply to that running config. So if I go in here and I change my configuration by typing configure, enter, and then putting host name as Tyler, for example, it'll switch it from the 6300A that was on there to just Tyler. And so if I look at my running configuration now, if I type show run and tab it, it will complete it. I'll go down to where it says host name. So show running config, there it is, host name, and that's it. Now, if you don't want to have to scroll through the whole thing, you can do show run and then put like search commands with a vertical pipe there. You can type things like include host name or the word host, and it will do a string search and produce just that one line that you're looking for. There's a bunch of little tricks like this, but we're going to keep it nice and simple and just go in and do our thing. So maybe the first thing we want to do for security reasons is shut down our unused ports. That's probably a good idea. So looking at the configuration here, we can show not only the config that's on there, but we can also save it as we go along as well. So I'm going to make some changes. I'm going to set up the interfaces as shut down, and then I'm going to bring up only the ports that we want to use in our example. And if you look, if I just want to look at this part of the network for right now, I don't want to have any uplinks to anybody else. I don't really care about the management port because that's already working, but I do want to have port 1 and port 3 here working. Yeah, so how can we set this up so all the other ports are down and only those ports are up and running? That would be really good security. So first things first, I'm going to change my host name back to 6300-A. Cool. And then let's go in and let's shut down all our ports. So the first question is, how many ports do we have? Well, we could do a show command and look at our interfaces, but rather than showing all the interfaces and adding them all up or looking at the first and the last one, you could do a show interface brief, for example. So show interface question mark, and there's the brief option. Let's do that. So I'll do show interface. I'll just up arrow to reprint that and then type brief. And when I do, it prints to screen. After typing that command, it shows a column listing ports, the mode the port is in, whether the port is enabled or not, and whether it's up or down. Like you might enable a port, but if it's not plugged in, it's going to be enabled, but down. Or you might have a port that is not enabled, in which case it's administratively down. And that's actually what I want to do. In this simulated switch here, I don't actually have 48 ports, even though if I look, it goes all the way to 48 ports plus 4 uplinks. Those actually aren't connected. I could tweak it, but I'm not going to do that. Out of the box, it has 10 interfaces that we're going to play with. But that's just because it's a simulated switch. In a real world, you don't want to do all of these ports. So the way that I could take a port is I could say interface 111, and I could say shutdown. Oops, sorry. Let me go into the interface, pressing enter, and then you'll see the prompt kind of shows an interface there. I could just simply type shutdown, and the port is shut down. How do I know? I'll do a show interface brief, and it shows me the status is now down. Not just down, it's the reason it's down is because it's administratively down. That's me. I'm the administrator. I administratively down that port. Pretty cool. Now, if I actually want to use that port, though, that was a bit of a mistake. I want to bring that back up. But before I do, let's shut down all our reports. So instead of typing up arrow until I get interface, and I change that to a 2, press enter, and then do a shutdown. And then I press up arrow and change it to a 3, and then I type shutdown. You can certainly do that, but you can see where you start seeing typos and stuff. Here's a one-stop command to do it all. Just type interface 111 dash 1152. So the entire gambit, the range of interfaces, it now brings it up and it shows you the range that I'm under. I can type shut sweet. Now, did it work? Let's do a show interface brief. And yeah, sure enough, they're all administratively down. These are down, but it doesn't say why they're down because I actually can't use them anyway, so it doesn't really matter. So it's just these first 10 that I care about. But nonetheless, they were part of the first 52, so that matters. I want to bring up ports 1 and port 3, so I'm going to exit out of here, and I'll type interface 111. Instead of a dash, I'm going to put a comma 113. Enter. Now I'm under those 2 ports. I could have a bunch of ports, but I'm just going to put that in there. And I could do a no shutdown. Did I say shutdown? I meant no shutdown. And now those ports are up and running. How do I know? I don't until I test it. Ah, look at that. They are indeed up. And they're up because these 2 devices are plugged into them. If I were to take one of these devices and stop it, then what it should show, I don't know if it will because it's a simulator, but it should show that port 1 is down. See, and it doesn't. It should though, but it doesn't. But in the real world, it would, because there would be nothing plugged into it. So the circuit would be broken, basically, on the cable. That carrier would not be reachable. So anyway, I'll go ahead and bring that guy back up. So that's pretty good. We showed the range shut down. We no shut it back up. And then to see MAC addresses that are discovered, we need to see if our PCs can actually talk to each other. So again, we're only looking at, these are all disabled. We're not looking at this. We're not looking at that. We're just looking at PC1 and PC3 and seeing if they can talk to each other through this switch, because they're not directly plugged into each other. That would require additional NIC cards. You generally wouldn't want to scale that way. So how do we do this? Well, we go back to our switch. There's our switch. And do I see any traffic? One thing about simulations like this is that your virtual PCs, they generally don't create traffic. So if you do a show MAC address table, and it's MAC-address table, what that should show you is learning MAC addresses from your devices. And actually, I did. My switch learned the MAC address, the layer 2 address, from this PC. Now, these switches, although they're capable of seeing IP addresses, by default, 6300s are just switches. They're layer 2 switches. So I could change them to routed ports, and we can do gateways, and we're going to do that later. But for now, most switches that are, well, switches that are layer 2 switches, they are layer 2 for a reason. They only see MAC addresses and the physical layer 1 ports they're plugged into. And they build a table. They build a table saying, I learned this MAC address on this port. It doesn't see PC3. And the reason it doesn't is because PC3 hasn't generated any traffic yet. So if I go to PC1 and I validate that that was indeed the address I used, and remember, this isn't a PC like our Windows PC is. If it was an actual PC, I would type ipconfig all, and I would look to see what my Ethernet adapter or MAC address would be. So I got to find my Ethernet adapter. There it is. So that would be the MAC address that my switch sees in my house. But for this Linux machine, I need to know what its MAC address is. So I'll do a show IP, and that shows me the name of the PC, my IP address, and I even have a gateway in there. And then I have this MAC address. If you do a show a PC all, it kind of lays it out a little bit easier for you. There's the MAC address that my PC has when it sends a frame to the switch. And so on the switch side, when I show a MAC address table, look at that. It's the same exact MAC address. In this way, you can validate that they're reachable not only at layer 1, because the port is up, but they're reachable at layer 2 because they can see each other's MAC addresses. Pretty cool. Can we see PC3? Well, let's open up PC3. I'll open up PC3 here. So let's do the same thing. Show IP all. And sure enough, we have a MAC address there, but I'm not seeing it on my table. So I need to generate some traffic. So the way I can generate some traffic is I could just ping something. Let's ping 10.251.12.1. Can PC3 see PC1 at 12.1? This is the address of PC1. This is the address of PC3. So will this work? Well, it turns out it does. It does work. That means frames are traveling from here up through the switch down to PC1, and the response is coming back as well. For that to work, this switch in the middle needs to learn MAC addresses from PC3, learn MAC addresses from PC1, build a MAC table. That's what switches do. They build these lookup tables. And when your PC1 sends a frame or PC3 sends a frame to this address, it actually resolves to the MAC address of PC1, and it reaches out using that MAC address to reach PC1. The reason why we're only using MAC addresses, really, even though the IP addresses are there, is because we're just talking layer 2. These are just switch-to-switch connections. There's no routed gateway required. So that means if I look at my MAC address table on my switch, I show MAC address table, I should now have 2 entries. I have the entry for PC1 and the entry for PC3 based on the ports they're on. And yeah, sure enough, that should be PC3 here, ending in 6804, 6804, and there you go, PC3 on port 3. Yay, it worked. Woohoo. So we learned how to do the running config. I'm going to show you how to save your configuration. We showed the interfaces, we showed interface brief, and if I wanted to see more stats, by the way, you could open that up on the 6300 and do a show interface 113. I don't even have to type the whole word interface because it already knows what I'm talking about. But this will show the status is up. This is the switch MAC address, not the one that we saw on there. But it does show the rate of how many packets are coming in, how many packets we received, how many bytes worth, and how many we've transmitted between these devices. So how do I save all this fancy work that I did? Well, the way that you save your work is you copy that running config somewhere. And you can copy it to a lot of places. You can copy it to a remote TFTP, SFTP server, whatever. You can save it as a checkpoint, which means I could just roll back to this. That's kind of cool. So if I copy the running config and I want to save it, the simple command is just write memory. This is a shortcut. And what it does is it should create a checkpoint. But in the real world, it would create a checkpoint called startup config. Because these are emulated, we're going to save these a different location, which we don't have to go into. But when we boot this switch, it copies the text from a location called the startup config. So if I copy the running config to the startup configuration, that's the same thing as write memory. And it now creates a startup config that if I show that, it's the same text in the startup config. That's what I'm showing. It's the same text now that was in the running config. So for example, if I show the startup config, press enter, you see the host name is 6300. If I then go to config and change my host name back to, I don't know, change it to elephant or something like that. I'll call it pickle. Cool. My name is now pickle. If I show the running config, it's going to reflect that my host name is pickle. But if I show the startup config, it shouldn't say pickle. It should say the 6300. So if I reload by typing boot system, it'll ask, do you want to save your changes? If I say no, it'll say, okay, we're going to reboot it. And I'll say, okay. And it reboots. And it reboots pretty quickly because this is a virtual machine, but it ignores what I configured because I hadn't saved it. When I changed my configuration host name to pickle, that was in my running config, but it wasn't saved. So if you reboot, if you have a power outage and you didn't save, you lose those settings. Or a positive way to think of it is if you make a mistake, you can just blow that out by rebooting your machine. If you don't mind an outage, if you have a maintenance window or whatever, and when it comes back up here in a minute, then we should see that it boots up with the host name 6300A as opposed to pickle. So yeah, pretty cool. So that's the syntax. You copy from somewhere, like copy from the running config to a checkpoint, or copy from the running config to the startup config, or you can copy from the running config to a TFTP or FTP server or SFTP server or whatever. That's fine too. All right, so take a look at layer 3. We're looking at the network layer of packets, establishing communication across multiple LANs and WANs. And with this, we're using our devices not from a switching standpoint, but from a routing standpoint. And the way I know that is I have circles here. Circles, when we design our networks, those usually indicate that we're talking about routers. But all a router is, like the wireless router at your house, it's just a way of going from one switch with a bunch of devices in them where they're all part of the same network to another switch network with a bunch of devices that have a different subnet. And the way you know these subnets are different is because of the subnet mask saying that this is the subnet identifier. And the subnet mask here, it could also be /24. This is the subnet identifier. So all your devices over here are going to begin with 10.0.1 something. The way we say that is we just put a 0 in the host column for this example because it's a /24. So the net ID should be 10.1.10.0/24. And then this host down here, you might have the address of 10.0.10.5/24. And this guy, he might have the address of 10.0.10.48/24. As long as it could be any number from 1 to 254 that's available in this 4th octet, because the subnet mask is masking the first 24 bits to say everybody has to have the same first 24 bits. It all has to be a 10.0.10, 10.0.10. So when I put a 10.0.1, that wasn't correct. Over here on the left-hand side, same thing. If we're using a /24, we're saying the first 24 bits indicate the network, which in this case is 192.168.10. The host portion is just a unique identifier on that. So this guy, this other guy, they're going to have some address that's going to begin with 192.168.10. something. So the network is known as 10.0/24, but then the address for this guy might be 192.168.10.2/24. And then down here, this guy, he might be 192.168.10.18/24. He could be all the way up to 254 if he wanted to, /24. There is another address in here that I haven't shown, which is the address of the router. The router itself also needs an address in that subnet in order for this to work. So if I look at the router is going to have some IP address in the same subnet, 192.168.10. something, and it could be .1, it could be .254, it could be .17. It doesn't matter what it is, as long as it is not being used by anybody else. Same thing over here on this side. I'll just use a different color. The router's probably going to have a 10.0.10. something. Let's say 254/24. As long as it begins with the same subnet, zooming to /24, mask those first 24 bits, then this is going to make sense. So this addressing, when it comes to networking at layer 3, the goal is to establish routability between this original source and maybe this destination. If we want to send packets to this user over here, we need to know what the IP address is. So when I send a packet, my user or my application will type in what the destination is, or maybe the name and DNS will resolve it to this address. But one way or another, I need to know I'm going to 10.0.10. something. And then what you do is you take that destination and you line it up with your existing network. And you realize, since you're a /24, that these don't work. They don't line up. If I was sending a frame on this switch to, say, this other user over here, and I was sending it to 192.168.10.5, for example, this was .5, then I could just send it. I wouldn't have to go through my gateway. But since it's going outside of my subnet, your PC is smart enough to know it needs to route it to the gateway first by sending it to the gateway MAC address. So it'll destine it to the gateway MAC address. And then the gateway should know how to get it this way or that way. What's the best way to reach this destination? This gateway function, this router function, is called routing. And it's what your router does. Your router knows about these foreign networks over here that exist, or it has a default route to get out to the internet or whatever, but it has some sort of route in its routing table to reach that destination. So just like your switch, you could do a show MAC address table and see MAC addresses to interfaces. You can see your layer 2 MAC address in a column with your layer 1 ports that it learned that MAC address. The router does the same thing. It learns IP addresses or networks that it knows about, and then which interface is it going to use, or what next hop address is it going to forward it to that it's connected to in order to reach this foreign destination. So that gets a little bit in depth here, but that's basically the function of packets. They use this layer 3 address to determine these final destinations of reachability, this path discovery of what the best path is. Once it reaches that destination, it then uses layer 4, the final layer we're going to look at, where a port number designates this traffic, this data, as being a certain type of application data. If it is, for example, SSH traffic, then we would send it on TCP port 22. TCP traffic is a lot more reliable because of TCP than UDP. TCP just stands for Transmission Control Protocol. So depending on the port number that we use, we can forward this from host A to host B, and host B should be listening. If it's running an SSH server, it would hear that traffic. We also do error control at layer 2 with the frame check sequence, at layer 3 with the checksum, and again at layer 4 with the checksum, regardless of whether it's TCP or UDP. So the final layers are really those application layers, as I described before, with a web browser, an FTP server, an SSH server, DNS server. There's literally tens of thousands of different applications that you can map to using the 65,000 ports that you have available.